My name is Anurag, and I work for a company called Nagarro. A quick introduction in terms of what we do. We basically help our clients scale up when it comes to the AI tech stack. So what I wanted to talk to you about was this topic of scaling, but mostly from the perspective of economics and engineering. And we feel that this is a fairly important way to think about AI amidst the many different ways you can think of this. So that's the topic. And first things first, it's really important to talk about the general hype around AI, which is obviously there at some level. At the same time, there is a bunch of truth in the kinds of use cases that are possible today with AI. If you have a view of a business person, you would look at use cases from a value and an ROI perspective. If you are a data scientist, you'll look at it from a tech possibility perspective. But there is just many, many different ways to really discover AI. And one of the things we do as part of our engagement with our customer is really think about what use cases would really very easily can be unlocked for a customer. So that's one important thing. But then the other two important things that are equally important from a measure is that are some of these use cases scalable? And what does scalable mean? So there are two important ideas. One is, can I have 10,000 people access an AI application and it doesn't fall off? The second important thing is that can I keep my costs at such a level that it would be economically viable for a company to run this, right? So those are the two important things that I think are equally important in measure in addition to the number of use cases that you can think about. Now, what's the elephant in the room, right? The elephant in the room is, this is the way most people engineer today with AI. Let's build a quick prototype. Let's call OpenAI. Let's call Anthropic. Let's call Gemini API and build something quickly. And the elephant in the room is the bigger the model, the better it is. You all have seen GPT 4.5 come out. I don't know how many of you have seen the reviews, but clearly a bunch of us are trying to see if that really changes the average quality of outcome that we have been getting from GPT 4.0, for example, or the Claude Sonnet 3.7 and so forth, right? Now this is really important because with these kinds of models, the claim that I'm going to try and make is that it is economically not possible for us to really scale both in terms of efficiency and in terms of performance. There are several challenges that go down that road, right? Now, there are two ways to engineer this. One is think about things like, hey, I have to have queues, and I have to have caching, and I have to have my Postgres combined with the vector SQL database, and it should all be very economical. That's what we call conventional engineering. But then there is this whole other engineering that is around model selection and using models and LLMs and large multimodal models properly. And it is that topic that I think I'll just shed some light on. Yeah? So let's start. With a very simple application, I am practically going to be very surprised if most of you in the room or your organizations are not building a chatbot, really, right? Like the simplest generative AI application that you can think of. I have a person, they want to talk to a bot, and the bot uses all kinds of very interesting things to really get something going. But let's just pry open that box, like what's inside this chatbot, really, right? And you will see that if you want to build a good quality bot, it is not just as simple as calling an API and just getting it done. There's a whole bunch of things here to a serious engineer who's trying to engineer with this application is going to think about. And the important things are, for example, what if the question that the user is asking is not smart enough? Is the quality of response dependent on the kinds of questions that get asked, or should I nevertheless be able to answer the question really, really smartly? If you want to do that, you have to have something called a query enhancement. If you do not do that, your retrievals are not going to work. You're going to retrieve from unstructured data, you're going to retrieve from structured data, you're going to do a whole bunch of retrievals, followed by some kind of LLM query selection. Maybe you choose some kind of visual. So a simple act of building a chatbot actually is a much more interesting and an involved phenomenon. Now, where am I going with this, right? So take it to the next level. This is a simple data flow of a single query at any given point of time. If you just walk it, and please don't be intimidated, I don't really want to talk about the technologies involved, but there are at least 6 LLM calls that are happening in answering one query from a customer. That's how many LLM calls are being made at some level. Now, these are some things that we are doing every day, day in, day out. And when we build a rapid prototyping thing, it looks really awesome. I can show you, but when we really try and build it in a production system, a query like this is going to take about anywhere between 7 to 10 seconds to return. And your customer hopefully does not get frustrated in that 7 and 10 seconds, not to mention that you would have spent about close to 30 cents just making those LLM API calls. So just opening the box and building engineering with it, you really see the challenges that come with engineering and economics around this. And so what we really are feeling is that this is the place where a company and an org gets a Gen AI going, but they will not go from that one use case to the 5 use cases to the 100 use cases, because they're going to run into a whole bunch of issues. And that's a key stumbling block that you have to remove and reduce at some level. You have to find ways to really improve this to the next level, really, right? And the key things that you have to think about, but the gist of the matter is somewhere we need to change our mindset about the bigger is better to smaller is faster and economical. And how do we do this? So there are kinds of strategies that have been around. These are not new. A lot of people in the machine learning community are very, very familiar with it. What we try and do is try and get to our customers, talk to them about some of these obvious engineering optimizations that exist, which can really change the way they build simple apps, but that consequence of that simplicity can turn into some real amounts of possibility of actually scaling Gen AI into many, many different use cases. So let me give you a brief view of what some of these strategies look like. They're fairly simple and important to understand. One of the key things is quantization. Very simply, it means, and the metaphor here is I have an image. Let's say you have an image at a certain resolution. What you do is you reduce the resolution. If you do something like this, you save a lot of memory bits and compute bits. And if you do that, you suddenly are very, very economical. At the same time, it's very performant. So you do similar approaches with large language models. You take their parameter space. A parameter is a number. You reduce the precision of that number. So a 32-bit number reduces to an 8-bit number, and that can lead to an exponential amount of saving in terms of what you can actually save performance-wise and cost-wise. Right? Now, there are all kinds of approaches to do this very, very quickly, but there's post-training quantization, like you actually train your model first and then you quantize, and there's something called quantization-aware training, like you are aware of that there is quantization, and you ensure that when you're training, you're actually building a quantized model. The second idea is pruning. Very popular idea. We use a lot of it when it comes to image models and audio models. Very simply, think of a plant with lots of little shrubs and branches growing. Not all of those branches are interesting. It's a neural net. You can reduce a few. And you just take away that, and you can very quickly make a much bigger model, a much smaller model. And a 1 billion space model or 2 billion parameter model is way more performant, way more economical, and can increase the chances of your organization succeeding with LLMs way more, right? So that's the second idea. I won't go again into the details of it, but lots of different ways that are possible for us to really make that happen. The third and the most popular technique is what is called distillation. And here it is where we see a lot of very interesting things happen. You have something called a teacher model and a student model, And what you do is you take the knowledge of the teacher and you put it in a student in a very simple way. So for example, I would ask OpenAI saying, okay, here is a picture. What do you think this picture is about? And it will give me, let's say in this case, hypothetically, it says 70% chance it's a dog, 20% it's a cat, 10% it's a zebra. And so I take those numbers, these are called logits, and I use that as a ground truth for a much smaller model. And lo and behold, I have the same quality, almost the same quality as OpenAI or a large language model, but in a much smaller, more densely packed model. There are many, many approaches to doing this at some level. It's not just one type, but there are several different types of distillation that are possible. But today, for example, in an enterprise, when we are implementing use cases, the key idea is that it's not about that one use case. It's about, can we go and set the path for at least 10 to 20 different use cases by building that infrastructure that can enable that org to really be at that level. And so model selection becomes super, super important. So just as a takeaway thing, it's really important to keep the economics and the engineering at the center, while, of course, value and ROI is super critical when we are thinking about Gen AI. So I thought it'd be a good idea to share some of the learnings that we've had from the many different customers that we talk to and work with when we work with Gen AI. Thank you so much.